We have more vocabulary, yay. Okay, so vertical angles. In order to get vertical angles, you have to have two lines crossing each other. And when two lines cross each other, you make basically an X. And these two angles are vertical to each other. That's a pair of vertical angles. And then this is a pair of vertical angles. So you get two pair of vertical angles across from each other. So you get two pair when lines cross. And then congruent angles are angles that have the same measure. And the symbol for congruent, again, is this little equal sign with a squiggle over top of it. So any two angles that are the same degrees, doesn't matter if they're pointing in the same way. You know, direction doesn't matter, it's size and shape. So if you have 30-degree angle and another 30-degree angle, they're congruent. If all 90-degree angles are congruent, all 45-degree angles are congruent. Something like that. Okay, complementary angles add up to 90 degrees. Okay, we can have this occur in two ways. They can be touching one another and make a 90-degree angle. And so we can have angle 1 plus angle 2 is equal to 90. Or they can be kind of out in space, like this. They don't have to touch, as long as they add up to 90 degrees. Now, when we put this little m in front, this is the measure. That's the symbol for measure. Okay, so this means the actual angle. And if I put the m in front of it, this means the degrees of the angle. Okay, and supplementary angles are a pair of angles which add up to 180 degrees. So same idea, they can be connected, in which case they'll connect and make a straight line. Or they can be off in space somewhere like this, where the measures will add up to 180. Now, the only thing I've come up with to try to remember which is which, if somebody compliments you, they are right. Complementary angles add up to 90 degrees, which is a right angle, right? So if somebody compliments you, they're right. That's the only thing I could think of to come up with a way to remember which one is which. So if you can remember complement is right, so they add up to 90, then you'll know supplement's the other one, and that's 180. Adjacent angles. Adjacent angles are touching and sharing a wall. Think of adjacent angles like a duplex. Right? You know, duplex is two houses that share that center wall. Think of the adjacent angles like a duplex. They're going to share a side. Okay. A linear pair is two supplementary adjacent angles. So basically, it's two angles that make a straight line. No, you can have, well, you can have an acute and an obtuse, because to add up, you'd have one acute and one obtuse, or you can have two 90-degree angles. Basically, what will happen is it's like this picture, except it makes a straight line on one part. That's why it's called a linear pair, is because when they make a straight line. So even if we went back to our vertical angles, where I had the circle and the square, one circle and one square would make a linear pair because they'd make that straight line. Here, I'll show you what I mean. Mm-hmm. A little different. Okay.
Because what happened was I took most of the class on virtual school, was like
Okay, and then an angle bisector, if I have just any old angle, we'll call him Bob. I come in here with, our angle Bob, and I cut Bob in half by putting a ray in the middle. That is an angle bisector. And when that happens, this angle and this angle are the same because I cut it into two angles that are equal halves. So bisectors cut an angle in half. Bob. Okay. All right, we have angle addition postulate, which says if D is in the interior of ABC, so I have some angle A, B, C, okay, and D is somewhere inside of it, then I can draw this other ray right here, that's D, and the angle ABD plus DBC will make the whole big angle. So if I number them, it might make it a little easier to understand the concept. So if we have 1, 2, 3, this is saying the measure of angle 1 plus the measure of angle 2 will equal the measure of angle 3. Basically, it just says you can add two small angles together and get a big angle. If they're adjacent, if they're touching each other, the two little ones add up to the big one. Does that make sense? Okay. Then we have the angle bisector postulate, which tells me that an angle has exactly one bisector. If you think about that, that makes sense. If I have some angle and I want to cut it in half, there's only one place where I can cut it in half and it will actually be equal halves. So, if I come in here with any old line, there's only one place where it will make it equal and equal. And then we have a linear pair postulate, which tells me that, and then purple is equal to purple. And then blue plus purple will equal to 180 because that's part of my linear pair theorem. Okay. If we want to find a complement or supplement, we subtract. So if I want to find the complement and the supplement of 35, the complement, because complement is equal to 90 degrees, I take 90 minus 35 and I get 55. And the supplement is equal to 180 degrees, so I take 180 minus 35 and I get 145. So anytime you're told to find, if I said find the complement of 46 degrees, I'll take 90 minus 46. So that's 50 minus 6. So that is 44 degrees. And then the same thing with supplement. If I had to define the supplement of 46, that would be 180 minus 46, which would be 140 minus 6, which would be 134. Pictures and sketches, I know you guys probably don't like to draw all these figures and everything, but when you draw them and label them, it makes understanding what to do next 100 times easier. So if I use a picture to solve for x and y, I have a straight line and another straight line. Let's make that one green. Okay. That tells me I have vertical angles. So this angle here is going to be the same as this angle here. And this angle is going to be the same as this angle. Well, that tells me y automatically because this one's already labeled. So y is 123. I don't even have to do any work on that. Now to find x, if I look, it's making a straight line. So x 123 together make a linear pair, so that means they're going to add up to 180. Does that make sense so far? So x is going to be 180 minus 123. So that's 60 minus 3, so 57 degrees. Okay. Complement of 56. Complement adds up to 90. So we're going to do 90 minus 56. So 90 minus 50 is 40, minus 6 is 34. And then the supplement adds up to 180 minus 93. So 180 minus 90 is 90, minus 3 is 87. Here we have a picture that has a lot more going. These pictures have more going on. I do have two straight lines. This one's a straight line. I'll just do this. And this one's a straight line. So that tells me that these two angles together here are going to add up to 180. Do you see that because of this straight line? So y is going to be 43 minus 180. Wow. 180 minus 43. So 140 minus 3, so 137. That's y. Now if I look at x, see how these two are adding together to make this 90 degree? So that means they're going to add up to 90. So x is going to be 90 minus 43. So 90 minus 40 is 50, minus 3 is 47. And in this picture, okay, x is over here. I've got y, and I've got 36 and y making a 90. So I'm going to do y first. So y is going to be 90 minus 36, which is going to be 54. Okay, so that means I know this is 54. I still need to find x. Well, looking at this picture, do you guys see I have a straight line here and a straight line here. So this makes vertical angles. So this one's 27 because this one's 27. Vertical angles are equal to each other. And then all three of these together will make this straight line. So all three of those together are going to add up to 180. So to find x, I can take 180 minus 27 and minus 54. So that's going to be 153 minus 54, so 99. Does that make sense? That's not the only way to approach this. I could have taken the y, and if this one's 54, then this one is also 54, and I could have, manipulated it this way. There's more than one way to do it. You can have a compound sentence where you're asked to find, let's say, the complement of the supplement of 120. When this happens, when you find the complement of the supplement or find the supplement of the complement, you want to find the second part first. So we're going to find this part first, and then this part second, because you need to have this answer to find this. So first I take the supplement of 180, or 120, so that's 180 minus 120, so that's 60. And then I take 90 minus 60 for my final answer to be 30. So it's sort of backwards. You start at the end and work your way back instead of going forward. So whenever you see this, you just know you have to do the second part first and then the first part second. Work it backwards. A conditional statement. If then, You guys have heard these your whole life. If you do your homework, then you can watch TV. If you clean your room, then you can play outside. Right? Those are conditional statements. That means that the thing that you want at the end has a condition on it, which is the beginning. Pretty much, yeah, pretty much. So conditional statements are written if-then. If is the hypothesis. It's the unproven part. Then is the conclusion. So if I write a statement, if you study, then, I forgot the word then, sorry. Then you will pass. Okay. The hypothesis is you study. This hasn't been proven yet because I'm saying if you do. Well, maybe you will, maybe you won't. The conclusion is you will pass. That's the then part. Now, a counterexample is any example that will show a conditional statement to be false. Sometimes there's only one counterexample. Sometimes there's 1,000 counterexamples or an infinite number of counterexamples. However, you only have to find one to make it false. So a counterexample for if you study, then you will pass would be that you studied and still failed. That would be a counterexample. That proved my conditional statement false. I said, if you study, you will pass, and you did study, but you failed. That proved me wrong. Conditional statements can be rearranged, and those have names too. We have the converse. You guys know the Converse tennis shoes, Chuck Taylor? You know how the little symbol is on the inside of the shoe, like the inside of your ankle instead of the outside where you'd think it should be? So they're flipped. That's the same thing as like a converse of a statement. If you flip it and you change it around, so instead of if you study, then you will pass, it's if you pass, then you studied. It flips the front and the back and changes it around. A biconditional is a statement that if you have a true conditional and a true converse, so you can flip it around and they're both true, you can write the phrase as one sentence with using if and only if instead of if then. And in math, if you write an if with two F's, it stands for if and only if. It's like extra if is. So it's if and only if. You just have to write IFF, and mathematicians will always know what you mean. You don't have to actually write out all the words. Our statement can't be a biconditional because we found a counterexample. You studied, but you didn't pass. So it's false. Both statements have to be true. So I'm going to write, if you stand in the rain, then you get wet. Oh, no, so no, my biconditional for that wouldn't be true either. Hold on. If you were born in Florida, then you are native Floridian. Or if you are native Floridian, then you were born in Florida. Both true, right? So I could write the biconditional, you are a native Floridian if and only if you were born in Florida. So if you take the sentence and you flip it around and they're both true, you can put the if and only if in the middle. So if you were born in Florida, then you're a native Floridian. That's true. if you are native Floridian, then you were born in Florida. That's true. So I can say you are a native Floridian if and only if you were born in Florida. Okay. Inverse negates the sentence. So our original sentence was, if you study, then you will pass. So the inverse is, if you don't study, then you won't pass. So basically we just put nots or don'ts or won'ts or things like that in there. Makes it negative. Oh. That's a typo. This should be contrapositive. Contrapositive is both flipped and negated. Okay, so I take the flip, if you pass then you studied, and I make it negative. If you didn't pass, then you didn't study. Okay, examples. We did that already. Stating the hypothesis and the conclusion. The if part is the hypothesis. So you can just write hypothesis. And then the then part is the conclusion. Okay, converse, we flip them. So I take, if Sheila is a terrier, then she is a dog, and I flip it. If Sheila is a dog, then she is a terrier. So converse flips. Inverse is negating. If it is raining, then Charlie carries an umbrella. I can just say, if it is not raining, then Charlie does not carry an umbrella. You make it negative. And then the contrapositive does both. So if Lauren is a girl, then she wears a dress. So I need to flip it. So put the dress first, the girl second, but then I make it not. So if Lauren doesn't wear a dress, then she is not a girl. True or false? False, right? Because plenty of girls don't wear dresses. Usually they're pretty easy to find a counterexample. Like if I say, if Lauren doesn't wear a dress and she's not a girl, you'd be like, really? You're wearing pants right now. You know, so it's usually on these it's pretty easy to find a counterexample. So for homework tonight, you're going to do benchmarks 2 and 3 odds.